These are the network administrator commands you need to know in Windows. So the first command is ipconfig. Ipconfig is used to display and manage our computer's network connection settings. So we can see several adapters here. We have Ethernet adapter, which is disconnected. I'm using an Ethernet, and this Ethernet is tethering from my phone. So here we have Ethernet adapter 3. This is actually the internet. This is actually the interface where we are getting our internet. And then adapter 4. So this is the virtual network interface created by VirtualBox. So there are several things you can notice here. So you can see this IPv4 address, then there's default gateway, then there's subnet mask. So a subnet mask splits IP addresses into two parts. One part identifies the network and the other part identifies the specific host device. A subnet mask tells a computer or router if a target device is on the same local network or needs a router to connect. Our subnet mask is 255.255.250 and our default gateway is this address. If we need detailed information about the IP configuration, just say ipconfig then /all. So we get all this additional information. Windows IP configuration, host name, it now gives even the name of my laptop, primary DNS suffix, node type, IP routing enabled, Wins proxy, no. So Ethernet adapter has now given us additional information of our adapter, Realtek, PCIe, GBE family, and all these other things. Auto configuration enabled, yes. Ethernet adapter 3, which is the one we are using. Remote NDIS based internet sharing. So we are sharing internet with I'm tethering my phone with the laptop. Then physical address is this one. DHCP enabled, yes. So you can see it's giving you a lot of information, including IPv4 address, then DHCP server. This is the server. Default gateway is being used as the DHCP server. This is the adapter we are using for our internet. So as you can see here, our default gateway is just our phone is being used as a DHCP server here. DHCP server. You can see here Ethernet 4, which I told you about VirtualBox. So a description of VirtualBox, host only Ethernet adapter, and all these things. So wireless adapter, Wi-Fi disconnected, another Wi-Fi disconnected. All these are disconnected. The most important thing to note about ipconfig all is that it shows you the physical address. The physical address is your MAC address. So as you can see, it's this one. This is the physical address. This physical address is the MAC address. So let's check the MAC address of another one. Ethernet 3, where's the physical address? This is the physical address. So physical address of our VirtualBox is this one. So remember, all these IP addresses are assigned by the DHCP. DHCP is a network tool that automatically gives an IP address and other details to a device when it joins a network. So this stops people from having to set up every phone or computer by hand. So when we join the network, when we connected the network, we are automatically given an IP address. What if we want to give up the DHCP assigned IP configuration? What we do is we use this command. So ipconfig/release, and we can see here Windows IP configuration. No operation can be performed on Wi-Fi while it has its media disconnected. So it's refusing to release the IP for the Wi-Fi because Wi-Fi is not connected. Ethernet adapter, media disconnected. So that one is not connected also. Then we have Ethernet adapter 4. Ethernet adapter 4 is our VirtualBox. This is our VirtualBox. Then we have wireless LAN that's disconnected. Then Ethernet adapter 3 is the one we are connected to. So as you can see, the IPv4 has disappeared because we released DHCP assigned IP address. So what ipconfig release command does is it tells our Windows computer to give up its current IP address and disconnect from the local network. As even as we can see here, it has disconnected our internet. Unidentified network, no internet. So we need to connect it back, as you can see here. So to connect it back, you just say ipconfig and then renew. So as you can see here, just check it here, it has connected again. So it has given us another IP address and it has connected our internet. So that's exactly what you do. So remember, IPv4 address you can be assigned the same address if it's available. It doesn't necessarily mean it has to be different. So always remember, ipconfig renew asks the DHCP server to obtain or renew network configuration. The resulting IP address may be the same or different. So now let's say you are connected to the internet, you are connecting to the internet, but you are getting several errors like site not found. Yet the internet is connecting perfectly fine. What you do is you run this command ipconfig /flash DNS. Ipconfig /DNS clears your computer's saved list of website addresses so it can find fresh, correct connections. So DNS stands for domain name system. It acts like a phone book for the internet. Your computer saves or caches the numbers, IP addresses of websites you visit. This helps pages load faster next time because your computer does not have to look them up again all the time. So let's run the command and see. Flash DNS successfully flashed the DNS resolver cache. So always remember, ipconfig /DNS clears your computer's saved list of website addresses so it can find fresh, correct connections. But it does not reset your internet, renew your IP, restart your router, or repair your network adapter. So note that different. It specifically clears the local DNS resolver cache. So, and with that out of the way, let's check ipconfig again. Ipconfig. You can see it's still the same. The one we are using is Ethernet adapter 3, just this one. So we still have the same default gateway, the same IPv4 address. So now let's check if our device can communicate with other devices, the network. First things first, let's see if our device can communicate to itself. So to do that, we ping the local host. So ping 127.0.0.1. This is what is called the loopback address. It's basically the device communicating with itself. So let's see, it's pinging and you can see there is 0% loss, so it can communicate very well with itself. This tells us that our computer's local TCP/IP networking stack is functioning sufficiently to respond to loopback ICMP requests. This does not necessarily prove that my internet works, but it means that we are communicating with our own device. So after we have known that our device can communicate with itself, now let's ping our default gateway. So this is our default gateway, the address for the phone which is giving us the internet. So ping 192.168.42.129. As you can see, it's still 0% loss. So what is the gateway? A default gateway is the node or router on a computer network that a device uses to send information to outside network, such as the internet, when no other specific route is known. So our default gateway here is this. It uses this Ethernet, which I dated to my laptop. So it uses as the default gateway because this is where I can access the internet. So if it can reach the gateway, let's start now testing if it can reach the internet. Ping this 8.8.8.8. 8.8.8 is a primary public Google public DNS server address. It acts as a free global address lookup tool that translates human readable web names into machine readable IP addresses. So let's ping it and see if packets will be lost on the way. 0% loss, so it can reach Google's DNS server. So our device can communicate with Google's public DNS server. But what if we don't want to use the IP address itself? Let's use the name itself, the host name. So google.com. What happens? Let's find out. So it's still 0% packet lost. But you can see here it's saying ping google.com, then it gives the IP address. So what it's doing here is that it's resolving google.com to an IP address. So this is the IP address of Google. Of course, Google has several IP addresses. So at this stage, we have known that if we ping Google public DNS, it will respond. When we ping our local TCP IP stack, it responds. So remember, ping is an ICMP diagnostic tool. When you give it a host name instead of an IP address, Windows first has to resolve that host name. So there are two stages. So we have, let's say, google.com. So then we go to name resolution. Then we get the IP address. After the IP address, we get the ICMP echo request. Then we get the reply. Our next command is tracert. This is like traceroute in Linux. So we're now trying to find the path to the destination. So for example, when we ping google.com, of course it worked. When we ran it worked. But let's say there was an issue. Let's say the internet is working perfectly, but pinging Google, it doesn't respond. We'll need to find the path to the destination to discover where the issue is on the way. So we use this tracert and then the destination, which is google.com. So tracing route to google.com and it brings the IP address. So my internet was the issue. So now it's tracing correctly. So we can see the first one here is our default gateway. This is our first hop, and our hop has 3 probes. So the second one timed out. Look at what happened. It still reached the Google servers, Google DNS server, Google public DNS server. So what does it mean? Does it mean it's broken here? It is not broken here. There are several possibilities. A router can be configured to not to respond to traceroute probes, to filter certain ICMP traffic, to rate limit responses, to deprioritize responses, and otherwise handle traceroute traffic differently from normal forwarded traffic. Meanwhile, it can forward packets towards the destination. So remember, this is just the time that is set for it to respond. It doesn't mean this hop failed. It means that the time that it is required to respond took too long, so it timed out. Then it moved to the third hop, which succeeded, and it reached the destination. So tracert google.com is so messy. Let's try tracert 8.8.8.8. So this is Google's public DNS server. So let's see what happens. So I didn't connect the internet, so transmit error, trace complete. So let's trace it again. So when you see an asterisk, it means that the time tracert 8.8.8 it resolves DNS to host name. What if we want to skip all that? We want to skip the DNS resolve. Let's say you want to skip the DNS resolve part. You just want the IP addresses. What you do is you instruct Windows to not to resolve. So you say tracert and then -d and then the IP address. So and let's press enter and see. So tracing route 888 over maximum of 30 hops. As you can see, the difference between one is tracing route to dns.google. So it doesn't resolve the domain name to the host. It doesn't resolve the domain name to an IP address. So we just get the IP addresses. So the first hop is our gateway. So trace complete. You can see here it didn't resolve the host name to IP address, just an IP address there. So -D tells Windows don't resolve IP addresses to host names. This can make traceroute faster because Windows doesn't have to perform name resolution lookups for the addresses it encounters. Why is this -D useful for network administrators? So suppose you are troubleshooting a network and you don't care about host names. You just want IP addresses as quickly as possible. So you just say trace rt -d destination and you'll get it faster than if you just choose trace rt. You can also reduce the number of hops. So here we have 3 hops. You can reduce the number of hops. So you just say trace art and then dash instead of d, just say h. And then we have to specify how many hops. Let's give it 2 hops and enter. Let's see what happens to these asterisks here, because it usually times out at this second hop. So let's see what happens. My internet is so slow. It's not tracing route to DNS Google and we gave it only 2 hops. Yet we know there's a problem in the second hop. So let's see what happens. So as you can see, it timed out in the second hop because this is the hop where it times out, but it doesn't mean it gets broken here, because as you can see from the earlier ones like this one, it proceeded beyond the second hop and it finally reached the DNS at Google. So, but what if we give it 3 hops? So this is 3 hops, which is usually by default. Let's give it 3 hops, which will move back to similar to this one. So let's see what happens. So it has reached DNS at Google. So 3 hops will reach DNS, but only 2 hops doesn't reach there. Let's set how long our probes can wait for the response. So we can just say trace R and then instead of H we say W. This is a W, and then let's give it how many, and always know that the time is in milliseconds. So let's say 100 milliseconds, and then we want to reach to 8.8.8, which is public DNS of Google. So let's see what happens. We have limited it to 100 milliseconds. So it will work perfectly fine. But what if we reduce to 10? What happens if we reduce to 10? Let's reduce to 10 and see. So now we might get a lot of timeouts, but so it has reached the default gateway, request timed out, and then my internet is very slow. Very slow internet. I have to keep doing it. You see, it's moving very fast, but as you can see here, it's exceeding 10 milliseconds. So why is that so? So what you need to remember is that tracert has some implementation details around how it handles the probes, retries, and replies. So the observed output isn't simply as anything above 1 millisecond or 10 milliseconds or whatever, but W controls the timeout for waiting for replies.